Welcome to the Global Math Department, everyone. My name is Lee Natero, and I'll be your host tonight. Tonight, we're going to be hearing from Hollylynne Lee. Before we begin our session, I'd like to tell you a bit more about the Global Math Department. The Global Math Department is an organization that's run entirely by volunteers. To keep the free, high-quality PD, we need webinar speakers, webinar hosts, and writers for our newsletters. And actually, this is going to be the last season of the Global Math Department. We just announced that today on our newsletter, but we will be having, I believe, 5 more webinars and another newsletter or 2. So we hope you'll be able to join us for the webinars and you'll be able to read our newsletter. If you want to reach out to us, you can definitely email us at globalmathdepartment@gmail.com, or you can definitely reach out to us on Twitter. Before I introduce our speaker, I'd like to explain how our webinars work. Our webinars are recorded and are available about 24 hours after the meeting ends. To view the recording, you can use the same link you used to get here tonight. The Global Math Department community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. And if the chatter gets busy, I'll be sure to catch your questions for our presenter. If you haven't already done so, please introduce yourself in the chat, telling us what you teach, where you teach, and what your Twitter handle is, if you have one. And I know we have a lot of familiar people with us this evening. All right, so welcome everyone. All right, our webinar speaker for this evening is Hollylynne Lee, and she'll be sharing on the topic using CODAP to teach statistics and data concepts. Dr. Lee is a distinguished professor of mathematics and statistics education in the STEM education department at NC State University. She's also a senior faculty fellow at the Friday Institute for Educational Innovation. Her research expertise focuses on teaching and learning of probability, statistics, and data science in grades 4 through 14. She's an expert on the design and use of technology tools to facilitate students' learning of mathematics and statistics, as well as preparing pre-service and in-service teachers to use technology in mathematics. She situates her work in educational design in order to provide the best learning opportunities for students in K-12, for university students and educators around the world. And you are going to definitely be in for a treat tonight if you are not familiar with CODAP. So I'll turn over the presentation now to Hollylynne.
All right, so I do have dual screens here. So if you see me looking over here, it's because I'm trying to monitor the chat or looking up something over here. Hi, I'm really excited to be here with you all tonight and talking about one of my favorite tools, CODAP, which stands for the Common Online Data Analysis Platform. And you'll see me situated in an office. This is not my real office. This is the office of Trina Wilkerson at Baylor University. I am a faculty member at NC State, but I am on loan to Baylor University for the semester, and I'm teaching classes here. So my office is not as neat as Trina's. But anyway, I'm going to go ahead and get started so that we can utilize all of our time. And okay, why will my slides not advance? There we go. Okay, so at NC State, I am the director of HiRise, which is a hub for innovation and research in statistics education. So I'm a faculty member in the STEM education department, but I am a senior faculty member, senior research scholar at the Friday Institute for Educational Innovation. And it's within that institute that I direct HiRise. And we have several different research projects going on at HiRise. And for many years, we've been providing massive online open courses for educators in teaching statistics and data, and have been really trying to think critically of how to engage our global educators in thinking more about how to infuse data and statistics into our classrooms, specifically using the tool CODAP. So when Lee reached out to me, I was very excited to be able to participate in this. So our goals for tonight is to think about what might be a data-intensive approach to teaching statistics, to give you an overview of CODAP, and to really dive in and to show you some of the cool things that CODAP can do by sharing and going through some sample activities. So some of these diagrams that I have here on the screen might be familiar to you in some of the textbook materials that you've used about what a statistical investigation might look like. So going through the phases of posing questions, you might call it formulating questions or asking questions, collecting your data, considering where the data might come from if you're getting it from a secondary source, analyzing your data and interpreting your results. And so lots of these have been around for a long time. Our group at NC State has been trying to think about, in the era of big data and data science, how could we really expand and make some things a little bit more explicit in thinking about what a data investigation might look like that would be closer to what data scientists actually do and statisticians when they're working with data. And so I'm not going to go into a lot of the details on this, but I wanted to share that where we situate our work is really, instead of trying to make things more simple, we would like to start by making things more complex and to honor the complexity that's involved in dealing with data. And particularly in thinking about processing data, that a lot of time that is spent with data is trying to understand its structure, where it comes from, what you're going to be able to do with it, and how to organize it in ways that are meaningful for the questions that you're trying to ask. And sometimes we have kind of minimalized that in school, but now that we have tools that can really help us in that processing data phase, we really have the opportunity to engage our students in a little bit things that are a little bit more meaningful. So I don't want to spend too much time on this, but just to give you a sense on where our team is thinking about related to this. And so we tried to bring bigger data into the classroom. And here you can see some pictures of real students engaging with larger data sets, and all of the images they are using CODAP, but the data is bigger. It has many different cases to it. It has more than 2 attributes. I like to say that we do not live in a univariate or bivariate world, and our students are naturally multivariable thinkers. They try to look for relationships and trends among different variables all at the same time, and we should be capitalizing on that. And we have the tools to be able to help us do this. And so it means that we also need access to take such a data-intensive approach. You have to do it on the computer. Graphing calculator is not going to cut it, and we need to be able to use tools that allow us to visualize and link representations and facilitate simple coding and data moves that can help us process that data. So when I'm thinking about bringing all of this together in the classroom, I use a couple of design principles to guide my thinking. I really want the data that I'm using in classrooms to be real. It needs to be collected by students or authenticated by the teacher. So it's a secondary data source that the teacher knows is coming from a good place. It's multivariable, and it has different types of variable types in it. So both categorical and quantitative. It's large, and large is relative, and sometimes messy. So there might be missing variables, for example, missing values, for some of the cases. There might be data that is coded in a certain way, and you have to know that the code 999 doesn't represent dollars. It represents a code that there was no response. And so knowing how to actually deal with that in a data set. The data context that you're dealing with have to be engaging to students. So then I move on to think about the tools that I want to use. And as I said before, the tools need to be able to facilitate being able to act on the data in certain ways. And in particular, in being able to use to act on it in tabular form as well as graphical form. And we want to be able to have supports with visualizations that help us make sense of data through linking different representations of data. The tasks that we use need to have multiple entry points for different levels of sophistication. So that our learners are able to draw upon their contextual understanding, their understanding of ways of dealing with data and different statistical topics to be able to make sense of the problem at hand. And we also want the task to promote curiosity and deep engagement. So we're obviously going to be paying attention a lot to the ideas of tools tonight. So here is CODAP. All right, here's a screenshot of CODAP. And I think earlier on, yes, if I'm looking over here in the chat, I see Bill Finzer. And I am going to give a shout out to him. He is the lead designer and developer for CODAP and does absolute amazing work. And, you know, one of the things that he really does is thinking about, let's see. So Lee, I see you raising your hand.
That was accidental. Sorry about that.
Oh, okay.
Or I could use the emoji to clap and say thank you to Bill Finzer for the work that he's done.
Got it. But yeah, so I've been a longtime collaborator with Bill, and you know, he really listens to what the needs of teachers and the needs of designers, and tries to be responsive to that in building a tool that is going to work the best in the classroom that it can. And one of the absolute best things is that this thing is free, and there's no login required, so you don't have to have an account. It's really easy to use, and hopefully you will experience that tonight. And it works across different platforms. I wouldn't recommend using it on your phone, though I have used it on my phone, but you know, the bigger the data gets, it's kind of awkward to scroll around on your phone. But I would like to see if either through emojis or through putting some things in the chat, if you could put some indication of whether you have ever used CODAP before. So maybe a yes or a no if you have, or give me a heart if you have used. So I'm seeing some hearts and I'm seeing some yeses and nos. All right. So we've got a variety of different exposures to this tool. Excellent. So we're going to go right into thinking about 2 CODAP-enabled activities. So the first one is one of my favorites to kind of engage in, understanding roller coasters. And we're going to think about it as far as situated here in the U.S. I did notice earlier that we've got some educators that are situated not in the U.S. And hopefully some of the things we're talking about won't be too far afield for you to be able to imagine. So I'd like to take a moment for you just kind of take in these images of different roller coasters that you might see in an amusement park. And if you could put in the chat some of the things that you might be noticing about these roller coasters. What are some things that you see in the pictures? What do you notice about these roller coasters? I'm going to look over here at my chat and wait for some responses.
Hollylynne, do they need to see the CODAP website at this point?
Nope. We're just looking at, can everybody see the images of roller coasters?
We don't see the images of roller coasters yet.
Oh, so what slide?
It says activity 1, understanding the roller coaster industry in the US. So it might be a slide behind or something like that.
Yes, you all are a slide behind. So it seems like there is a pretty big delay when I advance my slides and when you all are seeing them.
Or it might just be one slide behind, maybe.
Okay, so if I go,
Yeah, now we're ahead
forward.
too. Now we see Cedar Point.
Okay, but I don't want to see Cedar
There we
Point. I
go.
want to see, so,
Yep.
all right, you see
Yeah,
them?
there we
Okay.
go.
That's crazy. Okay.
That's okay.
All right. So Lee, I'm gonna have to help you. You're gonna have to help me kind of make sure that we are on
The appropriate screen.
everyone
Yep.
can
Yep.
see
Okay, so
see
great.
what I think of they see. All right. So things that we notice, I'm starting to see some so Kyle noticed loops. Yes. All right. Steep, high, made of metal and wood. Wondering about the speed. Yeah. Oh, and the support systems. Yes, looking at all the architecture that is going into keeping those things vertical. How fast you have to go in order to make a loop. Mm-hmm. Yeah, emotions of scariness. Great. Does one go into the water? Yeah, it certainly looks like there's some splashing going on over there, isn't there? Yep, whether you're upside down or not. Where are they located? Types of seating. Yeah. Awesome. So one of the things that I'd like to point out is that this context and the things that you are noticing is that what you're immediately starting to notice is not just we can notice single attributes about a single coaster, but by looking at a couple different coasters, we immediately start thinking about how the coasters vary. All right, we're not using that term yet, but the things that you are noticing are things, some of them are things that vary between the coasters, like the seats, like the speed, like the materials. All right. And so helping your students get situated within the context and thinking about the different attributes that that roller coasters have gets them thinking about not only just about attributes, but how those attributes might vary from coaster to coaster. All right. Now, do you see the Cedar Point announces it's retiring? Are you guys on the same slide I'm on?
Cedar Point is not up there just yet.
Well, let me see if I can go forward.
There it is.
Okay. All right. So this was a news article back in the fall in September of 22 about Cedar Point retiring one of its roller coasters called Top Thrill Dragster. Is there anyone here that knows anything about this particular coaster? Looking over here at the chat to see if there's maybe, do we have anybody here that is from the Northeast? This particular Cedar Point is located in Ohio in the United States. Oh, good news that they're just redoing it and they'll reopen it again in 2024. I did not know that, Jamie. That is very good to think. Oh, and Emily has ridden it. All right. So we have a few people that know a little something about this coaster. Okay. So let's take a look at what I would do. And we're going to go through this quickly. But in a classroom, I would pick a particular coaster and have students actually then go and use the internet. So can you all see? Let me just stop and make sure you all can see it. I have a picture of the Top Thrill Dragster, and then I have a table on the left-hand side. Do you all see that screen? Yes, you can see it. Great. Okay. So I would have students go and find different information out about each, about these different attributes about the Top Thrill Dragster. Okay. So I already told you that it was in Ohio. And they can go and find out different materials, but I'm going to skip ahead so that I can tell you some of these attributes. So now you should see a screen that has the data filled in the table on the left. And so it opened in 2003. Great, you guys can see the data. Thank you so much. Its top speed was 120 miles per hour. The maximum height, 220 feet. And you can just see in that image how tall it is. All right. The ride only lasts 50 seconds, and it's made of steel and has a track length of 2,800. All right. So having students go and searching about a particular case, not only do they get to know those attributes, but what they'll also see is that different websites might report slightly different values for each of these. And so then they've got to make some decisions about which values they're going to use to report on their data. And so some natural ideas and statistics come up about measurement and the kinds of errors that are present in data. So going back to these pictures of the roller coasters, we could start thinking about some investigative questions, like how do different characteristics of roller coasters create different rider experiences? So kind of an overarching question that might get us engaged with the data. Or how have characteristics of coasters changed over time? And I like to start out with my students writing very broad investigative questions rather than ones that are very specific about, for example, top speed or height. So we start very broad, and then once we get into the data, then our question, we start revisiting that questioning phase and refine our questions. So now is when, if you would like to play along and go into CODAP with me, you certainly can. So this might depend on your monitor setup and how you're joining us tonight. But you are also welcome to just sit back and enjoy and watch and think while I do. All right. So I am going to switch over to a new tab. And so now I need to know if you all can see my CODAP screen. I'm going to reduce this a little bit. Oops, a little bit bigger. All right, so you guys can see CODAP. All right, and I have my screen set up. Over here, I tell you a little bit about this data set. This data set has 19 attributes in it and about 635 roller coasters that were built between 1915 and 2020 that were currently in operation in 2020. And we used the roller coaster database, which I have linked down here, as our source of our primary source of data. And then we filled in some of the missing data values using other websites. And we have a table that actually describes all the different attributes. So here's our data dictionary, or our code book, as some might call it, that gives us our definitions of our variables. And so those can be useful for students to think about. I currently have the data set up in a way where I'm looking at what's called a case card. And I did that to purposely connect with the table that I had back on a previous slide. And I'm going to enter, actually, I printed them out. I'm going to enter the information that we had here. So I have the first two filled out for Top Thrill Dragster. The city that it's in is called Sandusky, and it opened in 2003. Its top speed, what was that top speed? 120. And so this illustrates how you can enter data yourself into CODAP. But if you've got a larger data set, dragging in a CSV file is much better. All right, duration is 50. Type, it is steel. Oops, sorry, having trouble clicking in here. Drop length is 400. The length is, track length was 2,800. And the number of inversions when whether or not it flips us up and down is 0. All right. There are no inversions on this ride. So there's no loop. All right. So the question is the data already in CODAP? Yes, all of the data is in CODAP except the data just for the Top Thrill Dragster. All right. So the data that I was just entering here was just for Top Thrill Dragster. And now I'm going to switch to a table view so that I can show you the rest of the data. So the data that I just entered is now here in row 22. And I see actually that I should probably put steel being with a capital S so that it matches all of my other type here. So here is the data. And right now I have the data filtered where it's only showing me the data for Ohio. All right. And there's different kind of moves that you can make as a teacher. And even though I have all of the data right now for 635 roller coasters that were in operation in the United States, I've purposely chosen to just start by looking at the data from Ohio. Okay. And then we're going to actually expand what we do to take a look at all of the data in the United States. Right. And you might choose to do this in different ways, depending on where you're starting with your students. But if your students are just starting to deal with bigger data, it's one way that you can start with it's a bigger data set because there's many more attributes that they might be used to dealing with in a data set, but there's not that many cases. So in Ohio, we only have 35 roller coasters that were active in 2020. And so it is kind of like a medium-sized data set for these students. So let's think about, I'm going to move my graph over here, and let's pick one of our variables and consider what we might learn about it. So let's take a look at top speed. So in CODAP, I can take the name. I'm going to do this one more time. I'm going to take the name of an attribute, top speed. I'm going to click on it and drag it and drop it onto the y-axis. So this here is a graph window, and I could use my menu up here to actually open up as many graph windows as I would like. So here over here I have top speed. I could take max height, and I could graph max height over here. All right. And notice that if I have a single case selected in one graph, then that case will also be selected in the other graph. And then if I scroll over in my table, it will also show me a little bit about that graph. So this is what I mean when I talked about earlier of having linked representations. So all the data in these 3 different representations here, as well as the map, I can actually see where in Ohio this particular roller coaster is located. All right. And so these different representations are linked together. So I can think about, oh, wait a minute. So the coaster that had the highest speed, look at that. That was my Top Thrill Dragster. And it also had the highest max height. So one might think about, well, I wonder if that's true, like on the other end. So if this is top speed, what about ones down here? If they don't have a lot of speed, do they also not have a lot of height? And we can kind of start. And this is what students tend to do. They start playing around with the data, and they're often very much attracted to a single case. And that is to be expected and honored and built upon, so that you allow them to kind of explore these initial cases, because by going through that, they start developing some ideas about relationships. So students might start to think about, wow, I think there might, I don't know, I suspect there might be a relationship between top speed and max height. And I could take max height and I'm not going to do what you thought I was going to do. And I did not immediately go to a scatter plot. All right. Instead, I took the variable max height and put it on top of my graph here, and it basically recolored these cases on a scale representing low to high height. And even visually, I'm also now starting to see, wait a minute, it's pretty much going from light to dark as I go from left to right on my top speed. And just this type of representation can help the students as an intermediary step, can help them start to make sense of what they might see when you actually do create the scatter plot. All right. We might also think about max height, and we might think about back at our pictures. We had both steel and wood pictures, and one might wonder that, is there a difference between the height on steel and wood? All right. Would anybody like to, in the chat, anticipate if they think there is a relationship between the type of material that a roller coaster is made of and the maximum height of that roller coaster? If you have an idea, you can type it into the chat. Right, I see a guess from Leon, higher for steel, thinking that steel could be higher. All right, so let's take type, and I'm going to put type on my x-axis, my y-axis, excuse me. So I separated it by steel and wood. And in Ohio, they don't really have a lot of wood coasters. So I don't have a whole lot of wood coasters to actually compare to my steel coasters here. And I'm looking at this. I could think about the mean or the median. I actually did that in reverse of the way I said it, but the mean line is blue. So certainly I can think about that. The mean height for steel seems to be higher than the wood. But again, I don't have a lot of wood coasters, so I might question whether or not I actually have enough coasters to make any type of claim about this, because it's not true. It certainly is not true that all of the steel coasters are taller than the wood. In fact, I can put in a movable line, and if I add percentages here, so I can put in a movable line and put it about here where my where the range for the wooden stops. 46% of the steel coasters are taller, they're higher than all of the wood coasters in my sample. But 54% of the steel coasters, their height overlaps with the wood coasters. So, so steel coasters have the potential to be higher, but that doesn't mean they necessarily will be higher. But one might wonder, if I add more data into this, would this relationship change? All right. So what we're going to do is we're going to go back to our table, and we're going to restore all 600 cases. So now we're not just going to look in Ohio. I'm going to bring in all of the data. All right. And again, I would not do this necessarily this quickly with my students. We would actually explore this data set of 35 for quite a while, and they would be coming up with different discoveries that they had before we would actually bring the data back in. But for our time together tonight, I'm going to go ahead and restore our 600 cases. So now the graphs that I already made now don't just have my Ohio cases on it. They also have all 635. And so if I added on a box plot here, I can start thinking about things related to outliers. So both the wooden and the steel certainly have some outliers. So they have some coasters that are made of each type that are typically taller than the rest of the group. And I can see that the wood coasters, I can start talking about the variability. We've got a lot of variability with the steel coasters. So even though they can perhaps build taller steel coasters, we still build a lot of steel coasters that are not very tall. In fact, there's a good number of coasters that, let's see, Q1 here is 19 feet tall. 19 feet. Visualize 19 feet. That's not very tall. Okay. So one of the things that we can do is we can bring back in other attributes that I hid. So to try to make our initial data investigation a little bit more manageable, not only did I hide cases, but I also hid some different attributes. And so I think earlier I saw people talking about the design and the kind of how the cars are situated, the train on the track. So we have a variable about that. We have a variable about the scale, all right, whether it's considered extreme, thrill, whether it's a family or a kiddie ride, all right? So I'm going to take scale and I'm going to put it over top of my graph here. And I don't know what it just did. Why did it just do that? Let's see. Let's bring all that data back. Okay. So this icon up here rescales your graph. So if you ever do something and your data is not scaled appropriately, this helps to rescale your data. And so I have things colored here based on how they're what kind of scale the coaster is categorized, and our family, and particularly our kiddie rides. So we've got lots of kiddie rides that are made of steel, but they're not very tall. All right. So there's some explanations as to why we might have such wide variability here. But these extreme rides, even if they're made of wood, they tend to be on, by definition, they're going to need to go. If it's classified as an extreme or a thrill ride, it has some of those other kind of features to it, and height might be one of those features. So I'm curious if, looking at some of these variables, if someone would like to propose some variables they'd like me to take a look at. You maybe have a hypothesis or some variables that you just want to explore. Year built. All right. So let's see. I'm going to bring down another graph. Okay. And so there's a couple things that I have here. So I have year opened. All right. So my roller coasters were all in this data set. So we had some pretty old ones that were still in operation in 2020. All right. And so let's see, I'm seeing here, curious if the faster ones are newer. Okay, so are the faster ones newer? So let's see, for faster, I'm going to need my top speed. So we can color top speed here. And I could also put top speed on this axis. And I can think about, so I don't want to think about this necessarily as a scatter plot, but I want to think about how these are different, how these are colored. And so there's kind of the band of my coasters that are not very fast. All right, so I can think about here's my band of coasters that are not very fast. Here's my next band of coasters that are a little bit faster, and when they are built, I can see where on this axis they are built. And then I can keep going up. And so this is an informal way of being able to take my top speed and chunk it into different categories. And I can do that even in using other representations. I could also actually create a new variable and write some code to group top speed into to different bands of slowest to fastest if I wanted to. But what I'm going to do is I'm going to come back here and take top speed and put it down here, and I'm going to group it into bins. And so this is grouping this into bins from 0 to 20. So I have a bin size of every 20 miles per hour. And now I can take year opened and put this as an overlay to see if that helps me kind of make sense of this. And in fact, I had actually previously created an age category where I grouped the coasters based on when they're built into 3 different categories called older, recent, and newest. All right. And so I'm going to actually separate these by these age groups. And I'm going to take this age group and put it down here as well. All right. And so, Lee, I think you were the one that posed this question. Are the newer ones going faster? What do you think? Do my newer coasters go faster? And Lee doesn't have to be the only one that answers this. My box plot is certainly telling me about some of the variability in the different age groups. So some of the some of the ones that are faster are newer in this newer category. But here are coasters that also are going faster. And they're in my older and my recent categories too. So we've got less variability in speed with our older coasters. And so we can tell a data story about how the coaster architecture and the designs and the whole industry of roller coasters has changed the way that thrill rides are created, and that we had, if you look across a lot of the different variables, you're going to find less variability in some of the older coasters. And then there's much more variability in some of the attributes the older that we get. Okay, so I'm gonna stop this and move on. And so we're gonna go back to our my slideshow. And I'm going to skip this. I'm going to skip this video, but one of the things that my group does is that we go into classrooms and work with teachers, or we observe other teachers working with statistics lessons, and we capture videos of them. And the handout that is available for you all that has all of my slides on it does have this active link, so you can go and actually watch this video and see some students working on roller coaster data. But I am going to skip that for now and move on. This is just an example of something that a student did that I was working with them. They were having trouble actually interpreting a scatter plot, and I actually suggested, so they were studying drop and top speed, and I actually suggested that they put type in the middle. And they really didn't have a good way of describing the relationship between drop and top speed. But when I put, or I had them put wood and steel over top, and they start saying, oh, wait a minute, there's the pink ones are all grouped together. And they said a lot of wooden ones are slower and have a shorter drop, and the fastest ones are steel. All right. And so just by making the data representation actually more complex helped them actually make sense of the data. And so I think it's a very nice example of how expanding the complexity of what you give students access to can actually facilitate some better reasoning. Okay. I'm going to quickly kind of, so we've got about, I'm going to skip through some things. So let me actually just open up another CODAP file of some income data just to demonstrate a few other features of CODAP for you. So this is income data. So I'm going to switch, and I believe you can see, I think, my CODAP screen that has a map on it and a data table. So if somebody could give me a thumbs up that you actually can see what I can see, that would be great. All right, looks like this is it. Okay, so I have the data organized in a way on this screen in something called a hierarchical table. And so the data is organized so that all of the cases from a single state are grouped together. So here I can click on the row for Connecticut, and I can see, oops, hold on, I'm trying to make this a little bit wider. Come on. A little bit wider. Why are you not making it wider? There we go. Okay. So I have actually 25 in this particular data set. This data set comes from the American Community Survey, and it is of employed individuals. And from the American Community Survey, we can actually collect random samples. And so this is a random sample of 1,443 people that took the survey. And I only have certain attributes about those people actually displayed here. And I can see on my map, what this is showing me is just how many cases I have in each of my states. So the sample that I drew, I can see that these states here actually have many more cases in it than some of the other states. And that might be, it's kind of related to the population in some of those areas of the US. But one of the things that I can do, so I of course I can create some of the same kinds of graphs that I was doing before, where, for example, I could look at income wages and look at these people's income, and lo and behold, we may have expected this. We have a skewed distribution. And we might ask questions about whether there are differences between the income of males and females. And we can start to look at that and, okay, they're both skewed, but I see a little bit of difference in these distributions. I actually just used this data and some other data that we were drawing around income for about 2 weeks with a class that I'm teaching here at Baylor. But we can take a look at the income distributions between males and females, and we can start asking things like, well, what percent of the excuse me, sorry, wrong thing. What percent of the cases, the people in my groups are actually considered outliers? So I'm going to try to put this movable bar about where the outliers start in my graph. So this is an estimation. So to be considered an outlier in the female group, I need to make about 110,000, 111,000 approximately. And to be considered an outlier in the males, I have to make a lot more, about 147,000. And if I add the percentages here, I can actually see that up here in my male distribution, 7% of the wage earners that were male are considered outliers, but only 4% of the females. And you know, we also see, like we were seeing with the roller coaster, a lot less variability with the female income than we actually see up here with the males. So we see a wider spread between the median and the mean than we do for the females. And we have a lot more, a higher percentages of our males that actually have incomes that are considered outliers. I can select those outliers and I can see some things about them. All right. So all three of these are males. One of them is 46, one's 38, one's 43. They all have a bachelor's degree. So I can, there's certain variables that I can think about here. But one of the things that I'm going to do just to show you something that you can do in CODAP is in this hierarchical table, I am going to compute the average income. So by state, I want to know in each of my states, what is the average income? So I created a new column and I called it average income. And I am going to create a formula and I want to compute the mean of this column here, which is my income wages. And if I start typing it, CODAP is nice and smart and starts to say, hey, these are the things that start with INC. Do you want any of them? And yes, I do. I want income wages. So I'm going to compute the average or the mean income for each of my different states. And I'm going to take that variable and put it on my map. And wow, that orange is hideous. So I am going to change that orange to something that we might actually be able to see. And with this random sample, I can see that my income, my average income is higher in these particular states than it is in these particular states. And we could start having some conversations about what job opportunities might be in those different states, rural versus urban density, and how that might be contributing to things. And we might have some hypotheses that we could actually go and select more data for. And just to actually show you, there is a plugin in CODAP for a microdata portal that connects up directly to the database for the American Community Survey. And so with this microdata portal, we can actually retrieve random samples of data and use that to collect a new sample. And not just from 2017, but all these other years. And this is a great opportunity for students to actually come in here, think about questions that they want to ask, and be able to select data and be able to compare it. So for example, if I picked 1980 in 2017 and I wanted my attributes, I'm going to actually go very quickly and I'm going to do income family total. And we're going to get a sample of 1,000 people. So here's a new sample that I just got. And I'm going to bring up a graph. And I'm going to bring that income family total. And I'm going to sort it by year. All right. And this is one of those cases where I see, whoa, wait a minute. Who are these people that make like $10 million? 10,000. That's like, what is that? Okay. This code, you have to know that this code actually represents somebody. I think is that, oh no, that is not true. I think this code is, I think this is actually the maximum value that gets recorded in this survey. Yeah, I think that is true. And so I might select those and say, well, you know, I think I don't want to consider those. So I'm going to hide those cases and rescale and be able to compare this. And then we did this in my class. We have to think about, now, wait a minute, this is in $1980 and this is in $2017. So I could go and look up the translation that I would need to do in order to compute, to change the $1980 to be in $2017 so that I could actually compare them. I could write a formula and I could actually do that transformation of the data. And all of that can be done in here within CODAP. So I know that was super, super quick. I'm going to go back to my slideshow because so let me go back. Can everybody see this slide that says income in America? Are people with me? Give me a yes, hearts. Yes. So if you're interested in using some of that income data, there is a fantastic project called US Society Data. And that's where those examples were coming from. And they have complete modules related to income inequality and US immigration that are designed for middle school or high school. And they're absolutely fantastic. So I highly recommend them. I showed you the microdata portal. All right, I want to just step forward because we have about 2 minutes left. I have here, and you can have this on the handout of how you can learn how to use CODAP a little bit better. Some links to videos of kids using CODAP in classrooms. But I want to share with you that we just launched last week a new professional learning platform called In Step with Data. And this is a free professional learning. So all of you are here on a webinar, taking time out of your day to engage with new ideas and to think about how to put them into your classroom. And I'm a really big believer that teachers do want to engage in professional learning, and sometimes they have to fit it in at crazy, crazy times. And so we designed a new platform where teachers can come in and personalize their learning around teaching statistics, and you can do it on demand on your time when it works for you. So we've built this around a framework about what we think makes an exciting and supportive classroom environment for teaching statistics and data science. And we call this kind of a design your own adventure, where you can go in and you can do different data investigations and experience what it's like to do data investigations. We give you customized recommendations. We offer a couple surveys for you to take. And we give, based on your answers to your surveys about your goals for like what you want to learn in your different experiences in the classroom, we suggest different things that you can go and learn from. And we have a lot of different resources and different technologies that have been vetted by experts. And, you know, you can really expand your library of things that you can use in your classroom. So we hope that you would consider engaging in that. And let me just go back to, this is the website, instepwithdata.org. And, you know, if you are excited about what you saw here in the webinar and you would like to come and learn more, please join us online and engage with your own professional learning. And Lee, thank you. It is 9:15. We have gone to the hour.
Well, thank you very much. There's a lot of great resources there. I do want to point out that there is a link in the handouts tab on the chat, so people can definitely grab that, and they'll get all the links to all the different help resources so that we can have some time to explore this on our own. I definitely feel like I need to pretend to be a student and just play around with it for a little bit first.
Yep.
And yes, Hollylynne put the link to the In Step with Data into the chat. So thank you everyone for joining us tonight. Our next webinar is going to be on April 4th. And the title of the talk for that evening is Street Data from Implementing Building Thinking Classrooms in Middle School. And Amy Chang will be presenting that session.
Yay. And I think I saw Amy in here
tonight. I think I did as well. I think she was here to kind of see how things go with webinars here. Yep.
Yeah.
All right.
Yeah. All right. Are we able to save the chat?
Yeah. So I'm going to stop the recording right now.
Okay. Great.
So yeah.